Good morning, everyone. My name is Prakash, and I am from mechanical department. Here I am teach you mechanics of solids. So, coming to mechanics of solids. So it is nothing but it is the branch of physical sciences. It deals with the bodies which are in state of rest or motion. So these bodies are under the action of forces. So we have to study the bodies which are in rest or motion subjected to the action of forces. So this study is nothing but mechanics. So here the bodies are of two types. Those are rigid bodies and deformable bodies. So rigid bodies is bodies which does not deform under the action of load. Simply it will break or it will fail. So coming to deformable bodies, in deformable bodies deforms under the action of load. That means it has to change its dimensions either in length or width or thickness or some volume. So these type of deformations or change in dimensions acting on the body are called as deformable bodies. So here is the best example for deformable body and rigid body. So this is the rigid body. So in this rigid bodies, under the action of these two forces, two loads, the body remains same. If we increase the load, the body will remain same. If we increase the load which is not bearable, so then it will fail by two parts without exhibiting any deformation. So here coming to deformable bodies, so here the deformable bodies are deformed by action of these two forces or two loads because the change in dimensions of this body results in deformation. Coming to mechanics of solids, so mechanics is divided into three types, that is mechanics of rigid bodies, mechanics of deformable bodies, and mechanics of fluids. So here mechanics of rigid bodies is further divided into statics and dynamics, and dynamics is subdivided into kinematics and kinetics. That means here in kinematics we have to study the bodies which are in motion without considering the forces. Coming to the kinetics, we have to study the bodies which are in motion with considering the forces. So here, and the second one is mechanics of deformable bodies. So the study of deformable bodies under the action of forces are called as mechanics of solids. The study of these deformable bodies is nothing but mechanics of solids. So in this lecture we have to discuss about the mechanics of solids. Coming to statistics, so here there are some conditions, that is equilibrium conditions. So a structure is in equilibrium with a system of applied loads when the resultant force in any direction and the resultant moment at any point are zero. That means the forces acting on the system of the body and the counter to that resultant forces are also acting on that body. So if the body does not exhibit any failure, that means the body is in equilibrium condition. So in that equilibrium condition, the resultant forces and the applied loads are equal. And also for a system of coplanar forces, this may be expressed by the three equations of static equilibrium. Those are sum of forces along x direction is equal to 0, and sum of forces along the y direction is equal to 0, and sum of and also movements about that body is equal to 0. So coming to free body diagrams. So before going to learn about the mechanics of solids so to solve some problems, here we would like to know the free body diagrams. So what is free body diagram? Here the free body diagram is nothing but the diagram in which a rigid body is isolated from the system and all forces applied to that body and reactive forces as a result of mechanical contact are represented. So the best example is here a block is placed on the ramp. So here we have to draw the free body diagram for this block. So if we isolate this block from the system, that means we have to separate this block from the system. So here I am separating this block, and what are the forces acting on that block? Here frictional force is acting, and here the load, that means the weight, gravitational force is acting, and counter to that here the reaction, normal force or reaction is acting. So by drawing all the forces on this component which is isolated from the system, this is known as free body diagram. Coming to centroid. So centroid, the point at which the total area of the plane figure or a total area of the lamina is assumed to be concentrated is called as centroid. That means always the centroid represented in the geometric center of the body. It does not depend on weight of the body, it depends on the geometric center of the body. So the coordinates of the centroid is calculated with reference to the chosen axis. So an area can have only one centroid for all positions of the figure. In case of symmetric figures, centroid is located along the axis of symmetry. So here coming to this rectangular body, here the centroid exists at the center of the rectangle. That means here from length along the length it can be placed at half of its length, and along the width height it can be placed at half of the height, and this is the centroid point of this rectangular section. So coming to this semicircular section, so here the centroid lies between at the point 4r by 3 pi. So here r is the radius of the semicircle. So moment of inertia. So here the moment of inertia is given as sum of the products of each area in the lamina with the square of its distance from the axis of rotation. So it can be written as, so here I am considering one area. In that area I am considering some strip or a small element that is called as dA. So here from x direction it can be located at a distance of x. From y direction it can be located at a distance of y, and from the origin it can be located at distance of r. So if you have to calculate the moment of inertia for this area, the formula is it can be given by square of its distance from the axis of rotation. So here moment of inertia about x-axis is given by integral of, here why we are considering integral is nothing but, so here first we have to calculate the area of this element, and after that integrating this area we can calculate the total area. So that's why integral of 0 to its area, and from x direction along the x direction about x-axis the element is located at a distance of y. So that's why y square dA. Moment of inertia about y-axis it can given as x square dA, and moment of inertia of about origin is given as r square dA. So coming to the main topic, these are all the basics which you have to learn for better understanding of mechanics of solids. So coming to the main concept, stress. So here stress is nothing but resistance force offered by the body against the deformation per unit cross sectional area. That means when you apply a force or load on the body can develop the resistance force which is developed by the body, which is opposite to the applied force against deformation. So the applied force is called as the developed force is called as resistance force, and on which area it is developing, so that resistance force per unit area is called as stress. So here this is the formula for stress. So stress is equal to resistance force by unit area. So here resistance force we are considering as P. Why we are considering as P means, so here if the body is in equilibrium condition, the forces should be equal. So here the applied force is equal to the resistance force developed by this stress or developed by the body. So that's why the force is taken as P. So here units of stress is Pascal. So 1 Pascal is also we known as Pascal is nothing but 1 Newton per meter square. It can also expressed in kilonewtons per meter square or mega Newton per meter square and giganewton per meter square. So coming to the types of loadings, there are different types of loadings. That is, first compression loading, tension loading, torsional loading and bending load, and also shear load. So these are the different types of loadings which we have to analyze and draw the solution for the given problems. So and also coming to deformations. So when you apply a force or load on the body should undergo different types of deformations. Those are either body should be shortened. So shortened in the sense, if the load acting on the body is compressive load. If the body is elongated, then the load acting on the body is tensile. If the load is twisted, the load acting on the body is torque load or shear load. Or otherwise, combination of these three loads are combination of these deformations also. So these are the different types of deformations. So coming to the strain, when a body is subjected to some external force, there is a change in dimensions of the body, as we already know. So the rate of change of dimensions of the body to the original dimensions is known as strain. Here strain can be indicated as either E or this E, this symbol. So here E is equal to change in dimensions by original dimensions. So here the change in dimensions we can indicate it as delta L, and original dimension we can indicate it as L. Here the strain has no units.